Let me just go back and really quickly talk about this, something that showed up in that discussion that is not at all obvious, which is that, the fluid is observed experimentally to have the same speed as both of the solid boundaries that it touches. So in that example that I gave you, I said that the bottom plate is stationary and the top plate moves. And then I drew basically basically an interpolation of the velocity that goes in between 0 at the bottom and u at the top. And that actually implies that the velocity of the fluid is exactly the same as the solid that it touches. That's actually not at all obvious. Like in principle, like if you didn't know any better, you might think that the fluid could slip past the solid, but in fact, it's observed experimentally that fluids behave as if they're attached to the solid surface beneath. If I have time at some point, I can explain to you why that is actually observed from a microscopic point of view, but this is an important observation that we will use throughout the class. Historically, it's called the no-slip condition. It's a boundary condition that helps you basically solve the equations of motion for a fluid, and we'll come back to it a couple of times in this class.